what you're going to see with the nervous system, so far as like, once again, we're going to see 3 layers of stuff, okay? We're going to see that this is electrical, so therefore we're going to have an action potential, okay? So we're going to see a lot of similarities to what we saw with the muscular system. We are going to find ions are going to be important. Once again, the ones that we've talked about consistently. We're going to see sodium, we're going to see potassium, we're going to see calcium, all right? We're going to see these ions be important because if something is going to be considered electrical, in our bodies, the way that we generate the electricity is by the ions. All of those little positives and negatives. What you're going to learn, the nervous system is one of the 2 systems that control the body. The other system that's going to control the body is the endocrine system. Every movement you make is going to be the result of the nervous system. Endocrine system is going to work by way of chemicals inside the body for the most part. Well, for our purposes, yes, okay? So these 2 systems are going to definitely coordinate together. When we begin to talk about the nervous system, for us, Chapter 12, but when you begin Part 2, a significant number of chapters is going to follow based upon the nervous system, because it is one of the 2 systems that run the body. So importance cannot be stressed enough about this system. When you look at what the function of the nervous system is, receive sensory input. Let's stop right there. Receive sensory input. First thing to identify, what is sensory input? What are the senses of the body?
Touch, taste, feel, sight, hearing.
Okay. We're going to find that we have what we generalize as touch. Okay? Feeling. All right? When we begin to say sight, sound, smell, taste, those are going to be classified special. Now, they're classified special for a reason, and it's because of the shape of their neurons and the proximity to the brain and how that information is going to pass. For our purposes right now, we are going to be looking at this general sense, okay? But we also have what's often said balance, okay? They're going to actually classify that under the special senses, all right? And then we've got to think about how the senses relate to the internal organs. Okay? So, we are going to focus on, for the most part in Chapter 12, this what we know as a general sense. What type of input, meaning information, is transmitted by way of this general sensation?
Environmental, from
Do what?
climate.
Okay. Climate, meaning temperature. How about touch? For example, did you think about your big toe before I mentioned it? Okay, but as you're sitting here right now, were you thinking about your big toe until I mentioned it? Okay, no, you hadn't. General sense. Alright, so when we say sensory input, it is so many pieces of information that have to go into our nervous system that if we had to monitor that information, we would go insane within just a few minutes. We are monitoring information such as the amount of light, the amount of sound, what is the smells in the area, taste, all right? We're measuring how to sit, information is going in about remaining upright. You've got information going in about hot, cold, pain, pressure, touch. This is not even beginning to hit the tip of the iceberg, okay? So that would be my monitoring sensory input. I've just mentioned monitoring everything that is external to my body. What is going to be internal stimuli that my body monitors for me?
Blood pressure.
Hold on, do what?
Things like blood pressure.
My blood pressure?
Temperature.
Pressure.
Well, I mentioned temperature, and that will be a part of internal also. External kind of playing a part in that. My respiration. Well, when you say which kind of muscle?
Yeah.
Do we have any other type of muscle? My smooth, my cardiac.
Toxins in the blood. Toxins in the blood.
Toxins in the blood, pH of the blood, oxygen level in the blood, CO2 level of the blood. Do you see where I'm going with this? The information that this system has to monitor is more than we could ever think about. It is monitoring the hair on your body. Think about the hair on your back, on your arm, on your shoulder, on your fingers, on your hand, on your toes, on your leg. It is monitoring every bit of that. Okay? So it is monitoring information coming in at rates that we can only imagine. Alright? Now, once it gets the information, it has to then make sense of the information. It must take all of that information and integrate it. The areas where all of the sensory information, everything that I've just mentioned, anything that is outside your body, anything that's inside your body, it is going to be integrated at the levels of the brain and the spinal cord. That is my areas of integration. Okay? Once the brain and the spinal cord integrate, process that information, we now have to determine what is the response that the body needs to carry out. So, how many of you, when I mentioned your big toe, moved it in some way? I'll bet all of you did in some way. Okay? Basically, I gave you some sensory information. What kind of sensory information did I give you? I gave you audible. Okay? I gave you something that you could hear. But I turned it into something that was skeletal, and I got a response. You moved your big toe. So do you see how that kind of works?
That's kind of like you get a new car and you start noticing all the cars that look like yours.
Well, the sociology people would take over that one. We're going to find that the nervous system controls muscles, and this is why often I was trying to get you to tell me not just skeletal, but smooth and cardiac also. And what else? Gland. Okay, you think about glucose. That would be the pancreas. All right. Any other glands you might think about? We've got our sebaceous oil, sweat gland. So not just, just glands as a whole. How about your adrenal gland? Yeah. Okay? Kind of cool. The job of all of this, not just the nervous system, but the endocrine system too, maintain homeostasis. Maintain my internal environment. Why?
Is it because the fluctuation of homeostasis can be detrimental? So, even something that we don't think about, like our blood pressure, having it too high or too low, your body can't maintain it.
And by the body being able to do that, having an area of the brain that is monitoring that for me, it will monitor the activities of the heart to match the blood pressure that I need. It's going to monitor the oxygen level to affect my respiration rate. Well, most likely CO2. But do you see how I'm looking at this? It's like, okay, everything I'm doing has to be monitored to make me do something else about it. All right? So, maintaining homeostasis, regulate and coordinate physiology. That means the internal workings of everything. 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 Think about that for a second. Physiology of everything. Heart beating, digestion, urination. You see where I'm going with this? Yes. Kind of amazing when you think about it.